You have 45 seconds. Is everyone doing good today? So, I guess before we get started, just want to shout out to all the DerbyCon guys who made this happen. Outstanding. Everyone doing the Adrian and all the guys taking care of the videos. Let's give them a hand. So how many people this is their first one? Oh wow, that's pretty good. How many people this is their sixth one? Okay. Wow. That's good, that's good. So it's 1 minute till I think we can go ahead and get started. You ready to start over there?
Yes, that's
all ready to go? So thanks for coming to our talk, Managed Mangled, Exploiting Enterprise Network Management Systems. My name is Deral, Heiland, Research Lead at Rapid7.
And I'm Matthew Pino, I'm an independent security researcher.
So as we get started here, I just want to give you a quick agenda and about what the talk's about. So we've done some research, me and Matthew, for, gosh, I guess it's going on a couple of years now, around simple network management protocol, covering everything from discovery type attacks all the way to injecting. So this is where we're at on the kind of final stage of that research, injecting attacks into network management systems using S&MP data. So we're going to start off with kind of going over what network management systems is. I hate to do that. I think you guys are smart at that. But often I encounter people when I say network management system, they take a double take and not quite sure what we're talking about sometimes. Then we're going to get into some of our methods that we use for targeting network management systems. We're going to get into the attack deliveries. The two key methods we deliver the attacks into the network management systems using S&MP data. And then we're going to get into the vulnerability discovery process, kind of how we lab the whole thing up and how we did our testing at a high level. So you guys can kind of go back and take that same approach if you want to look at similar products or even other network management systems we may not have looked at. And then we get into exploit demos. So far, I think the demos should go good, but demos are what demos are. So we have 2 live demos, and we have 2 video demos for some auxiliary type attacks that we did. And then we'll have some conclusion, kind of like some best practice ideas to think about moving forward around protecting yourself, dealing with network management systems. So let's start off. What is a network management system? It is exactly what it's called. It is an application or tool that you can install on your network, typically used on all mid to large companies for the purpose of managing your entire network. There's 3 key pieces of a network management system: the monitoring, asset recovery, and some visualization. So the monitoring aspect of most network management systems will take S&MP trap alerts. So if you have an incident or issue on a device in your network, it'll send an alert to your network management system to let you know that there's some kind of issue. The device has gone down, it's rebooted, whatever the case may be. It gives us health information about what's going on in your network. And it also can retrieve performance information. Often this is actually pulled through S&MP data also. And then we get into the asset management of that device. And this is kind of one of the key pieces that we utilize during the attack. And this is the ability to automatically discover new devices on your network. And then we get into, and this is typically done using ICMP, ping sweeps on your network, and then also S&MP data that's used to gather more information about the device and identification of that particular device. And then we get into the visualization of most of the products we actually looked at. So they have a way to visualize your network. So you can actually build diagrams of your network and location maps and communication paths. So you can visually take a look at what's going on in your network. A lot of these devices, they'll turn collars based on the device being up or down, having issues, whether their network passed down. So it gives us a visualization of the actual network that you actually are running. So now I want to turn it over to Matthew, who's going to talk about targeting network management systems.
Thank you, Daryl. So why did we decide to target network management systems? This actually goes back to when we started our research a little over 2 years ago. When we came together, we wanted to take a look at simple network management protocol. We also wanted to look at some sort of administrative software that used the simple network management protocol. And that research, we just started exploring simple network management protocol, playing around with it, getting familiar with it. And that's where we saw some information disclosure issues on embedded devices. We have a bunch of research out there on the Rapid 7 blog. You can check it out if you're interested. There's also the Hack in Paris talk from last year. That was sort of the final run of that research, so it's interesting to take a look at that if you have any interest in information disclosure vulnerabilities. But the reason when we come back together here is that we want to use Simple Network Management Protocol as the attack delivery. And network management systems are software that focus around Simple Network Management Protocol. They use that to gather information. And these software products commonly use or provide web interfaces, so that's also an attack vector that can be used. They're also of interest to attackers because this software is commonly deployed in mid to large corporations because you have a large number of assets that you're trying to keep track of. And what we found while looking at these is sort of a systemic security issue throughout these. So let's take a step back and consider the security impact that network management systems have on your network. They provide an attacker with network reconnaissance because these devices, or these software, are scanning everything from your endpoint nodes to critical infrastructure, and they're also monitoring and maintaining collections of near real-time metrics on those devices. You can see that that's a lot of useful information to an attacker. Because these software products reach out to various components on your network, they possess credentials to them. In many cases, you might have domain credentials on them to reach out and actually query systems and other sorts of access based on a particular product. The users of these products are typically administrative level and have elevated privileges within these networks. You can see if we can leverage the product to get the people who log into them. We now have another vector because we have elevated credentials. Fourth, because these products are monitoring your network, they're creating a lot of noise. Many of them do port scans on at least popular ports. Some of them you can actually expand into full and specify which port you want. But this is happening on demand, and it's also happening at set intervals. So they create a lot of noise just in acquiring all of this information. And from a systemic security issue, this really goes beyond the products that we have disclosures on. What we've seen is that there's sort of a common problem in this space, and that's that the network management systems trust the device data. Right? They're just trusting it. They're not filtering it. In development today, it's pretty common for us to be aware of user-provided data and the risks, and not filtering that data. Doesn't seem to happen in this space. At least that's what we found. And this goes beyond, an attacker putting a malicious device on those, feeding that data in. You could have valid devices on your network where an attacker has manipulated the SNMP data on them to contain an attack. So for current research to date, we have a total of 10 vulnerable products, 9 of which have been publicly disclosed. 1 is in the active disclosure process. It's due to come out early November. And across those 10 products, there's a total of 21 vulnerabilities. So we have the core of our research was SNMP as an attack vector, and then other things that we found while poking around these products. I'm going to turn it over to Deral, who's going to talk a little bit more about the attack delivery vector.
So the attack delivery methods we're mainly going to talk about today are dealing with SNMP discovery and SNMP traps. And we're also going to cover some of the other vectors that we found while we were poking around these devices. So the first one we're going to talk about is SNMP traps. In this particular case, a device, as I mentioned earlier, has an issue on the network. You can actually send an alert. That alert is gathered by the network management system, received by the network management system. This particular SNMP trap message is an SNMP message type 4 for those that are into the SNMP protocol. This goes over UDP port 162, and of course, it comes down to the actual trap ID. not all trap IDs can contain message data. An example would be a critical alert on your network. If a critical alert is being generated by a device, it's in an unstable state. So unstable state messages will normally not contain any message data. But when you get into warnings and alerts of other types, informational ones, a number of these actual trap messages can contain actual data. And this actual data or messages that we're looking at is the attack method that we're using to inject in. And this is done using a standard SNMP trap message. This is a Linux command. You can download the software and make this available. So kind of break down this particular trap message and how we should generate it. And in this case here, we're using trap message version 1. There's also a version 2. It's very similar. The syntax is a little different, but conceptually it still functions the same way. We can define the community string. Now, some of the attacks vary between the different devices. We had some devices where you had to actually know the community string, and then we had some devices where you didn't need to know the actual community string. So it would accept all trap messages actually sent to those devices, and we had several that actually had that vulnerability, meaning that we could actually not know anything about your environment, but if we had a foothold on your network, we could send an SNMP trap message potentially attacking your environment. And this breaks down, this is the actual target that you're targeting. This was the one that have UDP port 162 open, ready to receive the trap messages. And then we have an OID. These OIDs, two of them referenced here, can be anything. Absolutely anything you want them to be. It doesn't really matter. The one thing it cannot be that you need to be concerned with, if you happen to use an enterprise OID that is a valid OID of a device on your network, and you have those mid tables in there, then you have to match up the actual generic type ID and the specific type ID. If you don't, then it's not a match to the environment. So to carry out this particular attack, we just use any arbitrary, make it up if you want, OID. We actually set the generic trap to 6, which is for enterprise specific, and then we use ID number 99, which is a generic trap ID. And then it has the ability to contain a string message. And an example here, we're actually showing an alert box, a common alert box. So it makes it simple. You actually send this off to the device, and then in the device's console, since all these devices that we've encountered all have web management consoles, you have the ability to display that particular trap message. We can inject these cross-site scripting into these devices and carry out various attacks from, standard cross-site scripting, cross-site request forgeries, and even actual format string attacks into actual devices. So I'm going to go ahead and turn this over to Matthew, who's going to talk about the discovery method that we use.
So if you recall earlier when Deral was talking about what network management systems do, one of those is sort of the discovery process, right? It's going to find what devices are on your network. And part of that, it's going to detect the presence of the device in the ping sweep or the general port scan. But if it finds UDP port 161 open, it's going to go a little bit further, because it's going to assume that that's an SNMP agent, and it's going to try and query that device for the system objects. If it finds any of the system objects, it's going to retain them. And the reason is, here's an example on the screen of 4 common system objects that are typically supported, where you'll find set on a given device. And the reason these are important, both from an attack standpoint and user standpoint, is these describe the device, right? So a user is going, or a network admin is going to want these values in their network management system because they want to know the description of the device. And I mean, this is just a high-level description of what it is, maybe the software version, the firmware revision, the contact information of who set it up, the name of the device, where it's located. So these are going to be pulled during that operation and retained and then displayed within the network management system. And let's take a quick look at how we could do a simple attack against these. We set up our own agent. We're going to use the net SNMP package at SNMPD. This provides a simple agent. You configure that script, the configuration file for it. You'll set the agent address and right here, this is just a simple example. This is going to allow it to listen on all interfaces, both UDP version 4 and 6 on port 161. And then later in the config file, we're going to have two entries for the system description and the system name. And this is just where you have the text value that is the system object name, followed by whatever you want your agent to return. In this case, it's just a simple example of returning a script alert. We're going to restart that service, and then we're going to run an SNMP walk against the agent to make sure that it returns the values that we said, so that we're ready to then move this attack agent into the network for being scanned by the network management system. Beyond the SNMP-based vectors, this is where we started to explore a little bit and see what else was out there. And one product that I found actually had a command injection, and this is just where I was able to provide, it was provided via HTTP in this case, but I provided a command, and then the web server that's hosting the network management system executed that command. Deral has a few more to talk about.
So during the research, like we said, we also poked around after we checked for the SNMP type of attacks and looked at other possible things. And this was generally just low-hanging fruit. We didn't make hardly any effort, easy to find vulnerabilities. And we actually found SQL injection in two of the network management products we actually tested. Both of those cases you had to be authenticated, but you can be authenticated at any kind of control level. And it would give you the ability to, standard SQL injection attacks based on the back-end SQL server. You can do everything from, enumerating files, to executing code, to actually dumping the entire databases on the system. We also found forced browsing. In the forced browsing, we're actually going to have a video example of something, data that was leaked out of a network management system via a forced browsing attack. And then we failed to mention earlier that both the SNMP trap and the SNMP discovery method, we're going to have live demos showing those and showing us actually following through with an exploit type thing with cross-site scripting to actually show taking over the systems. And then directory traversal, I found another couple systems that allow directory traversals. These were both on Windows 2008 servers I was testing, basically giving access to the entire file system on the Windows device. The last one was kind of interesting. The format string one, turned out to be delivered through SNMP discovery. So it was actually a format string attack into the device via the SNMP discovery method. So how many people here know what a format string vulnerability is? Okay. So I assume the rest of you don't know what a format string vulnerability is. So yeah, I guess I have a minute to actually try to describe this. This is always the fun part. So a format string is what is an ANSI C specifier. So basically what it tells you is what the output of a function should be. So as an example, you wrote a program, and the program asked you what your name was, and you put your name in it. Like, my name's Deral, and it would say back, good morning, Deral. Fairly simple. So if the code was written improperly, they didn't specify the format string specifier. And normally it would be a %s, which would be a string output. If that was completely left out of the code, and I had that code in front of me, and it asked me what my name was, and I said my name's Deral, it would respond back with good morning, Deral. The vulnerability comes into place is when I put, instead of putting my name, I put format string specifiers in there. As an example, I put a %s or a %x in there, or %n, which are some of the most common format string specifiers. Using a %x, which is hex, tells the output should be hex. In that case, if I put a bunch of %x's in there, instead, a properly written program would come back and say, good morning, %x, %x, %x. An improperly written program with a format string specifier is not defined in the function at all. It would respond with data from the process stack. It would actually read data off the process stack. And the way that attack works is you can actually put data on the stack, read the data off the stack, and then use %s, which will read that input on the stack as a point of memory, giving you the ability to read arbitrary memory. %n will give you the ability to write arbitrary memory. So you can see how a full function exploit will be carried out. I was hoping to actually do that on this. I wasn't able to get a full function exploit on this particular case. So I was able to read arbitrary memory. I was also able to read the stack data, but I had some issues that kept running into me. Of course, we ran out of time, so I wasn't able to get a full functioning exploit. But those are some of the examples of the issues that we've actually discovered. So let's get into the vulnerability discovery process. So how we set up our particular labs. In this case, we use virtualized environment in my lab. Both of us did this. A typical Ubuntu system running VirtualBox worked out fine. We set up Linux, Windows Server 2008, and Windows Server 2012 based on the product we were actually testing. And that's how we labbed our systems up. Where we got the software was we took advantage of 30-day free trials. Most vendors allow us to do that. We turn around and set up these as default installs. That means we just said yes, 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 yes. Standard install on the device. We weren't worried about authentication, security, and things like that. We were purely looking at how these devices handle SNMP data. That was the focus of the entire research. So once we set these up, we had to go through learning the basic functions of the apps. This is horrible. Oh my gosh, this was horrible. So most of the applications that we found vulnerabilities in, most of them set up fairly easy, but there was a number of these applications. It wasn't like, yes, 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 it works. It was yes, 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 and nah, it didn't work. And in 3 or 4 days of reading manuals and making changes. So some of this was fairly difficult work. But then once we got everything up, we tested the various SNMP injections. We set up a device, had it discover it, what's it do with the SNMP data. We also went through the injections, the trap message injections. How does this thing accept trap messages? We'll take any arbitrary trap message, doesn't matter where it came from, or does it restrict it down to the community string that the device is set up. So we threw all that functionality, and then we carried out testing these vulnerabilities, stepping through every one of these products. And Matthew had pointed out earlier that we had found 10 separate network management systems where SNMP traps, SNMP discovery attacks worked on these devices. We only tested about 20 different products. So that's telling us 50% of the products out there are vulnerable. And I assure you, we did not test all of the products out there. There's a number. And some of the products didn't have 30-day trials. We had to sell our soul to the devil, the salespeople. So we weren't about to do that. So since we weren't going to buy the product, I figured that was totally unethical to go through some silly process like that. So we only tested the ones we could easily download and set up and run. And then after that, we come down to the ethical disclosure process. Once we found the vulnerabilities, we need to do an ethical disclosure. In this case here, we contacted all appropriate product vendors either via email or via phone. We didn't actually do this. This was done by Todd Beardsley at Rapid7. So shout out to Todd. Works his ass off, does a great job. It really helped out in this process. And then after 15 days, we contact CERT, let them know. And then 60 days after the initial alerting of the vendor, we publish it. And we followed Rapid7's disclosure process, and Rapid7 handled all the disclosure processes for us. And that's kind of how that works. So we're running a good time, so let's go ahead and actually start doing some real demos for exploits. So we have 4 demos, 2 live ones, and 2 video ones. I'll be in 2.
Alright, so I'm going to demonstrate an SNMP discovery-based attack in Spiceworks product. So this is just the home screen for the Spiceworks product, the vulnerable version at least. And let's take a quick look at the settings here. The particular attack, I wrote an attack that creates an account for a new user on the system. So we're going to go and check just to see what users currently exist in the system so it can prove that it's actually working. So you see here there's only 1 user and the admin role currently. So we have to set up the attack. And if you recall back from earlier in the presentation, I talked about setting up a simple SNMPD to host that attack. First, let's take a quick look at the web server directory on the attack system and take a look at the attack that I'm going to actually inject. We're going to skip over a lot of it. This was actually written in a car ride back from CarolinaCon. And we'll see here it's going to assign the first name of this user to as Dave, and then Kennedy the last name. And we decided to give him admin role in this system. So that's just the short of it. Let's get out of here. Let's go back. Now this is the SNMPD configuration. And we want to make sure two things. We want to make sure that it's listening on the right interface. You can see down here, we're set. This is the attacker's IP. So we're going to listen on that attacker's IP at port 161. And this particular attack actually leverages the system name object. So you see we have a few of the system objects assigned just general values, but system name is actually a script tag. And that's reaching back to the attack host, grabbing that JavaScript file that I showed a moment ago. So we put out there, we want to make sure that the net SNMP is at least restarted, that it's taken this configuration and reread it. So we'll just quickly run as service. Restart. And then you check the status, okay, we're running. So we're good to proceed with the attack. I'm going to go back in, I'm the admin. I'm going to take a look at the network scan option in this particular network management system. All right, here, it only is assigned one IP, and I did that just for the sake of making the demo run quicker. But normally, in a fully deployed network management system, this would be an IP block range or multiple IP block ranges. And these could be scanned on demand by the admin, or based on the configuration of the software, they'll actually be scanned periodically. In this case, I'm just going to do an on-demand scan. And scan, now this is the scan that's happening, so it's reaching out and trying to decide if that IP is active, possibly doing a port scan, or at least looking at port 161. When it finds the UDP port 161 is open, it's going to reach out and request those system objects from the SNMP agent. Yep, and as we see, the device has been inventoried. I did not click on anything while that happened, and you didn't see anything, bizarre happened either. We're going to go back to the settings and look at the user accounts now. And the demo gods have frowned upon us. Video? It's running.
Go ahead and start. Sorry about that.
Don't worry, I both believe you and you'll be calling my boss today.
What network management system are you using?
We're using SolarWinds.
This has actually been demoed a number of times without issue, of course, when it's live. It's
Welcome to the wall.
yeah. But we came prepared. There's a video of this.
Kind of speed it up to where you were.
Yeah, I'm just gonna kind of accelerate it to the end.
We built time in for this edge.
So you can see there. Here's that one's in there. There's the network scan that we just did. Device appears. Alright. So we go back to the user accounts, and that's where we actually have the account.
Move.
Nice. Turn it back to Deral to do a trap-based injection attack.
Trap-based video injection. No, in this case, we shouldn't have to, because we can get to that device, since I'm not using the server. So,
Can I ask a question on that?
yes, go ahead.
Is it, at what point does the JavaScript get run? Is it viewing it in the web page, or is it upon inventorying somehow?
So when the scan happens, it's being returned, and if you notice, like the little box that appeared had some, text values. It's actually displaying some of those system objects, like the system name. So the system name describes the device, so the interface is going to display that. Instead, it's injecting the script.
So it's in that box.
And then the script executes.
Okay. Great, thanks.
Hopefully this video will work. This will work right. So in this case, we're actually going to do a trap injection against the product event center. So I'm going to go ahead and log into this with a extremely complex secure password. Yeah, all the vendors, everything's been patched. If it hadn't been patched, we wouldn't be talking about it here. That wouldn't be fair to you guys.
What?
Wouldn't be fair to you guys. Since you may actually have no data, man. So in Event Century, we can see that we have a standard kind of dashboard console here. In this case here, this dashboard is completely configurable, and it can be configured to actually display the traps. I've not done that in this case here. So the trap messages typically fall under the logs S&P. So if we come down here, all the trap messages would show up here. They'll list them. You can actually see the details. At this point, we don't see any trap messages. Since I'm like really lazy at typing long strings, we will cut and paste this over here. We'll fire this up real quick. And as we see in this message here, this is similar to the one I showed you earlier. So it's S&P trap version 1 public. In this case here, we're actually going to do a script tag we're going to call code PHP. And what we're going to do is we're going to steal the session token and take over the console on this particular product.
If you're using a local IP, can you use something out on the internet as well for your source?
What's it out?
So you're using a local IP address, can you use something that's outside the network on the internet somewhere as well?
I mean, yeah, if the device is receiving traps over the internet, that's like really bad, but to each their own. I've seen worse. And it's probably not unusual. I've seen S&P exposed to the internet and S&P trap receivers exposed to the internet. If you can determine what the attack vector is, then you can potentially carry it out. Let's go ahead and run this. So we run this. So we just sent a trap message over to this particular product here, and let's see if it actually received it yet. So it did. So we look at the details, pretty straightforward, fairly simple, nothing unusual here. We see that some kind of trap message came in, but we can see there's actually no message there. Another thing I like to point out is that enterprise OID, this one right here. So 4.3.6.1.4.1.43555. If you actually see this on the network, you got bigger problems. This is actually registered to me. I own that enterprise OID. So if you actually see devices showing up on your network with that enterprise OID, yeah, I would probably do something really bad, really quick. You probably don't want that device on your network. So we went ahead and did this. Let's see if we can see if this is actually going to work for us. So there we go. We captured the actual session cookies from this device. The interesting thing on this attack vector here, this thing like actually totally kicked my ass, because if you notice the session tokens actually have quotes in it, and quotes are literally not standard or accepted within cookies. So all of my code kept truncating at the actual quote mark. So that's why this command up here, I ended up having to use this new image source, because the standard source wouldn't work, it would truncate. And that's why I ended up using that. But let's go ahead and see if we can actually carry out this attack and get it to actually work. So I have a browser over here. Of course, I would be logged in. You can shut that stuff down now. Let's go ahead and log out. Okay. Sorry for having to clean up the last minute. You think I paid attention, but I didn't. So let's go ahead and delete all that. So, L4, close that. We'll kind of refresh this. Let's go ahead and look at the cookie, because it assigns a cookie, but it's unauthenticated cookie on the particular product. You got Google selected there.
There you go.
Of course, we can't do this without a more fun one. Those that have seen my advisories that have gone out are probably familiar with this one. So we're gonna send a we're gonna go ahead and send our own special one. And come over here and go ahead and check details.
Good morning.
Customers love this one when I'm on their site. Gonna shut that silence down. Okay. So let's go ahead and we have a couple videos we're actually going to do. I'll turn this over to Matthew to show his command injection.
All right, so there's a product called Opmantech that had a really old version and a newer version that I found command injection actually exists in both. The older version was a little bit more interesting because it didn't require any authentication because authentication was disabled by default. So at least with the newer version, they had a whole user model with that product. And the other thing was that this is through the finger tool within the product, which was enabled for all users in the old version, and in the newer 8.5 version, you sort of had to add it. So in this case of what's being demonstrated, the system would have to be configured for the finger tool in this case. But what we'll see is the user who logs in has very low level privileges. In this case, they call it level 4 in this product, and that's simply guest privileges. And as we'll see after this user gets logged in, those guest privileges really don't give them much access to anything. In fact, the interface basically tells them they don't have access to a number of dashboard values that usually get displayed. But we know that the URL for the finger tool, so we're going to paste that in there in a moment. And basically the node that you're asking the tool to finger is where the injection occurs. We just simply escape at the end of the command and then tell it to run whatever we want. In this case, what I'm going to do is cat the user's DAT file, which is the Apache user config that this network management system is running under, and we get that Apache config. So now we have user accounts and password hashes for that system that we begin to crack, but really it goes beyond this demonstration. I can run any command, and that will run under the user context that's running the network management system, that web server.
So if you run it as root?
Yeah. Don't run your web server as a root. Excellent. I'm going to turn it back to Deral. He's going to do another demo.
In this particular one, we were talking about forced browsing attacks, a really common vulnerability found on websites, e-commerce sites, and various sites on the internet. In this case, we're looking at off-the-shelf software, your network management systems. They suffer from all the same problems. I think we've made a good point here so far. In this case here, we're going to look at some of the interesting data that can actually take. And this happened to be off-util managed engine product. In this case here, as we can see down here, there is a number of files that you can access. They all end with CC. So we can, and in this case, we can actually see all the accounts that are configured on the system. We weren't able to get the passwords, which I was really disappointed, but we were able to get a lot of information. Let's look at AD, we can get the domain, all the information. Good attack data, easy through a forced browsing attack. The second one we're going to look at is actually even better. It's maybe not as good as passwords, but it's second best when you're dealing with network infrastructure devices. So we see up here we have these dots. Never assume there's nothing behind those. Often there is. In this case here, we can go ahead and look behind, look at the actual source of this page. We scroll down and quickly find the actual so literally, forced browsing attack, we're able to gain access to basically all of these files that I'm showing here are all part of the configuration function of the device. This is a problem I've seen across a number of products, whether it's off-the-shelf product that has a web server, whether it's an embedded device, whether it happens to be standard commerce type web sites. These non-standard extensions often don't get picked up by the system's built-in authentication mechanisms. And that happens to be the case here. So all these CCs, we can gain access. So we see IP address manager, IP address manager input page, the IP mark report, audit view. These are all key configuration data structures of this product. And we can gain access to all that data. I mean, this would be perfect for on a pen test to be able to enumerate something like this and basically gather all this information. Gather the community strings, take the community strings against all your targets on your network. Typically, if the community string configured on this device, more than likely would be configured on other critical infrastructure devices. Since this is the network management system, it's probably going to be that way. And through this method, you can carry out these attacks and gain very, very useful information.
They leave those config files just in the root of that web server?
What's that?
Did they leave those config files just in the root of that web server?
Yeah.
Oh my god. Wow. Was their fix non-stupid? Or can't you comment?
I'm not sure. It's kind of one of those things. It's like we labbed up like 20 products with 10 of them. Did I go back and validate all of their fixes for every possible one? And the answer is no. Did I check some of them? Some of the vendors would come back and go, "Hey, could you revalidate this for us before we go out? And here's the code."
Yeah.
I often encounter vendors that do that, and when they do that and interact with me like that, I'll go through and revalidate everything.
Yeah.
Other than that, I'm going to trust them as professionals to go through and fix their code properly. And if they don't, we know what the consequences is. Somebody's going to come behind me, test this stuff, and it's going to be twice as embarrassing. So,
cool.
Okay, so moving from there, kind of the conclusion. We're closing down on the end of this. So we want to talk about some risk factors and mitigation techniques. And we got kind of three things to think about as we're approaching this type of stuff. The first one, implement a thorough patch management program. We worked with all of these vendors. They supposedly patched all of their products. Now, us as IT security professionals, we're not always the best at patch management. We've gotten really good at operating system patch management, right? So, but we're not good at patch management of applications and code and things on our network and things we purchase that are secondary on our network, not the primary operating systems. So we need to put together good patch management and consider all of these programs. Consider all the programs that are in your network operating system or within your SOC. that if an attacker can gain a foothold into those, I mean, it's game over at that point there. So it's important as we report these vulnerabilities that we implement a solid patch management program to get those issues fixed.
Yeah, and we really need to consider the risk of machine-to-machine communication. I think today, everyone's really good about dealing with user-provided data. We're validating it, we're filtering it. But I think machine-created information has largely been ignored, at least in this space. And that's sort of your development side, but also consider that from deploying software, that might read data from machines and what the risk is for the particular deployment.
The last one we want to talk about is monitoring your network management systems for abnormal behavior. I mean, it's simple to look at. If I'm doing a pen test or attacker is on your network and he targets your network management system as an actual example and gains a foothold like we showed how really easy it is, at that point we can actually use those devices, carry out pivot attacks on your network, use them to run our own scans on your network. That should be abnormal behavior. You should know what your device is doing. You should know when it runs scans, what it probes, when it probes, how it does that, and create a footprint of its behavior and put together or implement some method for these type of devices and these type of applications. Because I've used this attack before, not these specific attacks, but attacks of these type of systems. I've gained access to critical security management products on corporate networks before, and then use that particular product, that particular machine, and those particular rights of that machine to carry out attacks throughout the entire environment, and had the security operations center totally ignore it because that's normal behavior. That's what that device does. But the thing is if that device does that stuff on Saturday night at 2 in the morning, it should be doing it on Sunday morning. Or in the middle of the week. Those are behavioral changes that should be monitored in your actual environment. So moving from that, it's kind of the conclusion. Here are some links. These links go off to these advisories. We also released a full white paper. It covers every bit of this on Rapid7 sites. So it covers all the products, the whole methodology, the attack methods, how we set up our lab, how we set up and test these devices in detail. So you can literally take that white paper and reproduce all the research that we've been doing. And I don't know, we're at 45, so any questions?
Actually, I want to say one thing. So I tweeted this morning asking what network management system do you use. We looked at a bunch of software, and that's just what we found, based on articles or poking around. But I'm curious, what people actually use. You guys showed up to the talk, so it obviously interested you. I'm curious what you guys are using. So, reply to that tweet or something. Let us know what you're using.
Also shoot us out a tweet if you like this presentation, if you like this type of research. Often we do these things and we don't get, in the hallway we get a handshake and, hey, we liked your presentation. I often like to have a little more interaction, so shoot us a tweet, let us know you liked it. We really appreciate that. Yes, sir.
I guess, was all this against SMP version 1 and 2, or did you guys have success against version 3?
All of this research here was against 1, 2, but I mean, the general fact is the only difference between 1, 2, and 3 is the security. So, and literally, if I gain any kind of information on your security and I compromise the authentication methods of SMP3, which is possible, anything's possible, at that point all these attacks would still work. Because the same underlying functionality of SMP is the same across all 3 products. The only difference was 3 is basically encompassed in the security model.
Yeah, even if it queried those securely, it's still going to display the values that it queried. So the system objects would still be displayed.
The traps may be a little more difficult, but the discovery attack would not change. It would still work against the 3. Especially if you altered something on your network. Because that was one of the things Matthew had pointed out. Not all of these products you could actually change a device already existing on the network, but there are a number of products out there that if I compromise some low-hanging embedded camera on your network that's SMP enabled, and it's part of your constant discovery, and I change the information about sysname, sysdescription, syslocation, then it's going to consume that data and change it in your network management system, making this attack viable there also. So, any other questions real quick before we close down? Well, thank you very much for coming.